Hello, my secondary math 2 class. I hope your quarantine is going great. We are starting 16.3's lesson right here. We have 16.3. This is all just proofs. The whole lesson and the assignment contains problems 1 through 6 are, well, 1 through 5 are proofs where you're stating just the reasons as they go along. And then 6, you have to do both statements and reasons. And then 7 through 9 statements and reasons on the proof. So I'm just going to do a couple with you, show you what to do. There should be stars of proofs by now. And then I'll let you spend some time on your own finishing up the rest of the proofs that we don't do together in our lesson. All right, so number 1. We have a proof here. Again, we have statements and reasons. You guys are very, very familiar with that. That's something that you know. Triangle congruence proofs, which are what we're doing here, are the easiest of all. They're very straightforward. You state each of the sides that are congruent, angles are congruent, and then show that the two triangles are congruent by whatever property we've dealt with, like side angle side, side side side, all of those theorems. Now notice that in these you're proving that triangles are congruent. So I'll go through that and we'll do a couple here and a couple on the back, and hopefully by then you'll be just great with the rest. All right, so you're given that PQ is congruent to ST. Now it's very important that you mark these as you go. So that side PQ we see right here is congruent to side ST. Mark them with the little dash. That says those two are congruent. You can also color code them. That might help. QR is the next one, is congruent to TR. All right, if you want to color code those, you can do a double dash. All right, so now we have two sides that are congruent. The last statement says that R is the midpoint of PS. Now this requires you to remember what the term midpoint means, the definition of it, and what information that gives us if we know that R is the midpoint of PS. And if we know that, that means R is right in the center, and this segment PR is congruent to this segment PS because of the definition of midpoint. Now, what we have is we have a side, side, side scenario. We have a side congruent to a side, side congruent to a side, side congruent to a side. I like to write that down, side, side, side. Once I do that, and I know it's side, 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 then all I know in my proof is that I have to make sure that I prove that each of those sets of sides, which there are 3, of course, on a triangle, are congruent to each other and state the reason. And it's that simple. And at the end, after you've proven that this scenario exists and it's true to form, then you can state the triangles are congruent because of it. So PQ is congruent to ST. That's going to be given, this information right here given, and that's one set of sides. So I like to just give myself a little side out there. I've proven one set of sides are congruent, and now I have 2 more to go. And then QR is congruent to TR. So QR is congruent to TR, and that's also given. That's my second side. I have 2 of the 3 stated. Now, the last bit of information doesn't say a side's congruent to a side. It just tells us that R is the midpoint of PS. So if R is the midpoint of PS, that's given. That's great information because by definition of midpoint, we know that PR is congruent to RS, or PR is congruent to SR. Now, you might say, well, why does it say PR and not RS? Why does it say PR and SR? And that is because we're very formal in our congruence proofs with triangles. And if our PR are the first and third position, we have to make sure that we state the same position with our second segment. So SR must be written in that order, not RS. So PR is congruent to SR. It's very important how the sides and line up. You have to make sure they're all lined up properly. So that is going to be our third side, and that is by definition of midpoint. All right, and with that, we have our final side. It was a little more difficult to get to because we had to use definition of midpoint, but we still got that. So we have all 3 sides congruent, and because all 3 sides are congruent, that's our shortcut method to state that triangle PQR is congruent to triangle STR, and that's by side, side, side. All right, always check to make sure that you write it in the same way that you're asked to, given the proof statement, so that you've done your job. And there it is. All right, and that's basically the steps. You just have to figure out by marking, you first mark, And then you figure out, well, what is the property that allows us to state that? And you find your side theorem, and then you make sure that you state every single part of it directly in your proof. And then finally that the two triangles are congruent. All right, so the next one is number 2. Now we are given that SQ is a bisector of 2 angles. Now remember, bisector cuts an angle right in half into 2 equal parts, right? So if SQ is a bisector, let's locate that bisector. It's right here. That's the bisector. What I like to do is I like to mark it, as you know, and I like to have these 2 angles have to be congruent because SQ, RQT has been bisected, and then these 2 angles will be different in measure than these 2, but they will be congruent to each other because this is a bisector also of RST. So I have 2 bisectors here, and we have our 2 bisected sets of angles that are bisected by that segment QS. All right, so now that I have it all marked, I've analyzed and I see that I have an angle and then a side and then an angle. So that's going to be angle, side, angle. That will be our final way, our theorem that will prove that the 2 triangles are congruent. Now I have to make sure that I state these 2 are congruent, these 2 angles are congruent, this side is congruent. We know it to be congruent because of a property that we haven't used a whole lot before, and that's the reflexive property of congruence. We haven't used it too much, but it is a side of both triangles, and because it's a side of both triangles, and it's the same side, it will be congruent to itself by the reflexive property. And then we have this angle is congruent to this angle, and we have to state all 3 of those statements, and then once we've done that, we know for sure the triangles are congruent by angle, side, angle. All right, so the first thing, SQ is a bisector, that's given. Now we have to look at these. RQS, where is that? So R to Q to S, that's that angle right here, is congruent to TQS, T to Q to S, this angle right here. Those 2 are congruent by definition of bisector, because earlier it said that SQ is a bisector of RQT, and that's where we get the 2 congruent angles. And then the next one is RSQ, so this angle here is congruent to TSQ, this angle here. So if those 2 angles are congruent, that's also by definition a bisector, because in the given, it told us that SQ bisects angle RST. Right? And then the next statement is QS is congruent to QS, and note the order, Q to S and then Q to S. Those 2 are congruent because it is a side of both triangles, but it's the same side, or the same measure. So we would say that by the reflexive property, QS is congruent to QS. Reflexive property of congruence. All right, and then therefore the triangles are congruent by angle, side, angle. Now again, we have an angle. We've proven to be congruent, this angle, this to this. This angle, we've proven to be congruent. These 2 angles are congruent. And then we have the side between them, the included side. QS is congruent to itself by the reflexive property. So we've shown all 3 parts, angle, then side, then angle. Note too that we call this an included side, don't we? So we had to make sure that we used angle, side, angle with the side included between the 2 angles. All right, now I have enough time to do probably a couple more. So we'll do number 4 next. Number 4 is a double whammy. We have to state both the statements and the reasons. So we're gonna have to come up with our own little rules here. Oh, you know what? I wanted to do a parallel line one. I'm gonna do number 5 instead. So we have a number 5 that BC is parallel to EF. Now, I would mark that because that's important information. It gives us the scenarios that we need of those angle relationships between parallel lines and a transversal. So if BC and EF are parallel, then if I have this as a transversal, then I know alternate interior angles are congruent. So that's what we get from parallel lines. Also, D is the midpoint of BF, so this right here. So if D is the midpoint of BF, that tells us these sides are congruent. Now, one other thing we know is that this angle is congruent to this angle because they are vertical angles. They have to be because two lines are crossed right there. So with that in mind, we have to set up our proof such that we can prove these two angles are congruent, these included sides are congruent, and the vertical angles are congruent. So we're going to have an angle side angle scenario. All right. All right, let's get busy. So our statements. First, we're going to state that BC is congruent to EF. We know that for sure because it's given. Now, what do we get from that? What we know from that BC is congruent to EF, is that these angles are congruent. So I'm going to just say angle B is congruent to angle F because those are the only angles within the triangles at B and F, and it's not ambiguous at all as to which of the two angles I'm talking about. And that is because they are alternate interior angles between two parallel lines cut by a transversal. So we're going to say alternate interior angles as to why those are congruent. All right, so we've got one set of angles, the single marked arced angle. All right, now we're going to state that D is the midpoint of BF is given. And that's given. Now from the fact that D is the midpoint of BF, then I know BD is congruent to DF. I'm going to always check my statement here. Let's see. So BD and DF. Now, I'm going to go BD to FD because this angle is congruent to this angle, so I need to go 1 to 2. So BD is congruent to FD, 1 to 2. I don't have a statement to look at, so we'll have to deal with that here in a second. Now, if BD is congruent to FD, what we know that from is the definition of midpoint, because D is the midpoint of EF. So we would say by definition of midpoint. All right? All right, and that gives us this included side, the side between the two angles. And then the last thing we need is are these two angles. Now I can't say angle D because I got 4 and it's ambiguous as to which I'm talking about. So I'm going to have to do angle BDC. And then again, remember I have to stay in the correct order. So I went from 1 to 2 to none. So I have to go from 1 to 2 to none. So FDE, angle FDE. And that is by the fact that they're vertical angles. So vertical angles theorem. And that's my angle. Now, because of that, I know the triangles are congruent. So I know that angle or triangle BDC is congruent to triangle FDE. Now that wasn't, and that's by angle side angle. Now that wasn't what we were asked to prove. We were asked to prove that ED is congruent to CD. We're asked to prove that this segment is congruent to this segment. Right? Actually, I better just mark them with 1 because I already have 2 new stuff. So are these two segments congruent? Well, because my triangles are congruent, all of their corresponding parts are congruent. And yes, indeed, these are corresponding parts, so they're also congruent. So I can actually state that now that I've proven the triangles are congruent. So ED must be congruent to CD. And that's by, remember that CPC, TC that we talked about earlier? It was in the first section. Corresponding parts are congruent, triangles are congruent. Now we're going to use that as a theorem to prove that two corresponding parts are congruent, given that our two triangles are congruent. And that's proof 5. All right, so go ahead and try some. I might do another video, post another video tomorrow with a few more done for you. Have a good night.